Hi, my name is Andrew McConachie. I work for ICANN. One of the great things I get to do there is work with the DNS root server operators. And this talk is about a website I maintain with some statistics on it. So I press, cool. Okay, so what is RSSAC002? Quickly, RSSAC stands for ICANN Root Server System Advisory Committee. They have a series of documents, 002, which is now on version 5. It's basically it's a specification for a bunch of counters that root server operators collect. You can see the counters listed there, and they roll over every day. And what's good with a bunch of counters and data if you can't make pretty graphs? So I thought, well, let's make some pretty charts. And I first started in 2021, that was V1. I updated it again this year in 2024. And the major update this year was I added some data from RSS instances. So now you can see some pretty maps with root servers on them and whatnot. Important note is this is really just historical macro trend analysis. This is not an operational thing. There's a 3-week delay on the data. So this is not an operational tool. But I do have data going back to 2017. So it does make it kind of cool to see like what's been going on in the last 7 years. All the visualizations are interactive on the site. I'll just be showing some examples, but you're free to go play around with them as you wish. And it's open source. If you do have feedback, I'd really appreciate it if you open an issue on GitHub. That's the way. You can mail me too, but it's better if you just open an issue on GitHub, then I can track it. And a big thanks to all those lovely people there at the bottom who provided early feedback and late feedback and wonderful feedback. So here's the first chart, and I'm just going to be going through these pretty quickly, just to give you a taste of what's up there. There's a lot more up there than what I'll be showing and whatnot. And each one has a little story with it. So this is kind of interesting. I mean, you can see that traffic peaked to the RSS in late 2021, and that's because Google Chrome used to send these long kind of gibberish domains into the DNS, and then to check to see if it was on a public network. And they fixed that. And so since then, you see this like massive spike where it just goes down right after they fix that. And now you see it's kind of gone up back a little bit, but that was a big spike back in the late 2020. And you can see that reflected as well in kind of the ratio between no error and NX domains. So you see that on the I guess that's your left. You see also like at the end of 2020, like suddenly there's more no error and fewer NX domain as a percentage of total queries. And then you've also got a handy pie chart showing the same thing for this year. They're almost 50-50 actually. And that's like, the pie chart is pretty steady. Like it's been steady like that since 2021. This might interest people in this room, just showing the increase, the kind of steady increase, but kind of leveling off of IPv6 queries to the root. This is again a percentage basis. So you see it, 2017, it's at like 15, and then it's leveled off at like low 20s. Hasn't really moved. This is a fun one. So you may be wondering like what the heck happened in 2022. So this story here is there was some ISP in North America that shipped a CPE that was doing V6 priming queries every time it rebooted, but they were only doing them over V6. So the RSS got a whole lot of queries over V6, hence this massive mountain in 2022 that then just ended in the end of 2022. Okay. This one's probably the most complicated I'll be showing. Basically what I think the message here is that like packets to the root server system have just gotten larger over the years. That top line, that kind of dark purple line, is the 32 to 47 byte packet size of query. These are all over UDP. So you can just see it's been going down, and the ones that have been going up have been bigger packet sizes. So again, like kind of interesting to look at. Really probably not all that interesting operationally, but kind of neat. This is what I can do now with the new data set, which I can just show the number of instances over time. I can also show like IPv6 enabled instances or dual stack enabled instances. There's a few kind of staggering like IPv4 only instances out there, but there are no IPv6 only instances out there. And you can just see up, and that's pretty steady. It just continues to grow every year in the number of instances out there. This is a pretty map. You can zoom in on the pretty map and find more detailed pretty maps with more detail on each of the instances, and find the one closest to you if you're interested in that, and whether or not it supports v4 and v6 and all that. And you can also do it by letter. And that's it.